In this video, we want to solve some more complicated logarithmic equations using information that we've gleaned from the previous video. In the previous video that we saw that if we had a single logarithm equal to a number, or two logarithms of the same base equal to each other, then the equation would be fairly easy to solve. Here we have the sum of two logarithms equal to a number. So since we have a number on one side, we hope that we can get this left side down to a single logarithm. And we have a property that allows us to do that. The sum of two logarithms to the same base is equal to the logarithm of the product. So this left side, using that property, is equal to log base 6 of x times x minus 5. Now we have a single logarithm equal to a number, so write it in exponential form. And here we've gotten to a quadratic equation that we can solve either by factoring or using the quadratic formula. Go ahead and square the 6 and distribute the x, and then get everything to one side. And we get 0 is equal to x squared minus 5x minus 36. This is a quadratic that's factorable as x minus 9 times x plus 4. The solutions to this equation are 9 and negative 4. But remember that we have to check that our x values are in the domains of our logarithms. So a positive 9 is in the domain of both of these logarithms, since they will give us a positive argument. So 9 is a solution. Negative 4, on the other hand, is not in the domain of our first logarithm, nor is it in the domain of the second logarithm. So negative 4 is an extraneous solution. The only solution is x equal to 9. Let's look at a slightly different problem. Suppose we had log base 2 of x minus log base 2 of x minus 1 equal to log base 2 of 2x. We want to solve this equation for x. Well, here we have some logarithms on both sides. So since they are the same base, we'd like to get a situation where we have a single logarithm on one side equal to a single logarithm on the other. Because as we saw in the last video, that tells us that the arguments must be equal. Well, the left side we can write as a single logarithm, since the difference of logarithms to the same base is equal to the logarithm of the quotient. So here I know that the left side is log base 2 of x divided by x minus 1. So I have two single logarithms of base 2 equal to each other. Their arguments must be the same. So x divided by x minus 1 must be equal to 2x. This is a rational equation. If we want to solve this for x, multiply both sides by x minus 1. Distribute the 2x. And subtract the x over to get a quadratic set equal to 0. This quadratic is factorable, right? We can take out an x, and we get x times 2x minus 3. The solutions to this equation are 0 and 3/2. Right? But again, we have to check that these x values are in the domain of our logarithms. 0 is not in the domain of the first logarithm. We cannot take a logarithm of 0. So 0 is an extraneous solution. 3/2, when we substitute 3/2 into each argument, notice that all the arguments will be positive. Excuse me. So because of that, 3/2 is a solution to this logarithmic equation.